Hello, this is a tutorial on how to fill out a Punnett square for traits that show patterns of complete dominance. So we've got Gregor Mendel here, he's the father of genetics, and he discovered that pea plants show patterns of complete dominance, which means they have traits that are either dominant or recessive. Here's our table of dominant and recessive traits in pea plants. If, I moved it, let's move the arrows. If a pea plant has a dominant trait, that means it has a dominant allele. An allele is a different version of a gene. And for complete dominance, you can either have dominant alleles or recessive alleles. Recessive traits will show up in pea plants if there are two recessive alleles. So recessive traits can only show up if you only have recessive alleles. Dominant alleles will always dominate over a recessive allele. So you get an allele from both parents, right? And one from mother, one from father. If you got a dominant one from either one of your parents, that's what you're going to show. We call that our phenotype, what we physically express. So if you get a recessive trait from one parent and a dominant trait from the other, you're still going to show that dominant trait. And if you get a recessive allele from both parents, then you will show the recessive trait, but that's the only way it could happen. So let's use a Punnett square to predict the probability of offspring having certain traits. Okay, this is a Punnett square. You are going to draw this most of the time on your own. I have mine already drawn. It's a square with 4 squares inside. So you draw a big square and you draw a line through the middle both ways, vertically and horizontally. Each interior square represents a probability. So remember from our vocabulary that genotypes represent the set of alleles that you have, one from each parent, and phenotypes are the physical expression of what that genotype would look like. Let's pretend that we have one parent who is homozygous dominant for, we're going to go with our peas, we're going to go seed shape. So the dominant allele is round, and we'll use the letter B. Doesn't matter which letter you use, we're going to just use B. Recessive allele will use lowercase b, and that would be wrinkled. Okay, so to our Punnett square, let's say we have a homozygous dominant pea plant. Remember, homozygous means that both alleles are the same. So if both alleles are the same and it's dominant, then we have 2 dominant alleles. So we're going to take the alleles of one pea plant. We're going to start on top here with the columns. You're going to put one allele on top of one column and the other allele on top of the other column. So each column represents one of the alleles. All right? Now you're going to move over to the side and you're going to put the other pea plant, the other parent plant, on the left side. Let's say the other pea plant is homozygous recessive. So homozygous means the same, and recessive means lowercase. So we have 2 lowercase b's. Alrighty, we have a B in the first row and a B in the second row. 1 letter per row there. We don't put them on the right side and we don't put them on the bottom. I don't know why. I can't tell you. You just don't. Alright, so now to predict what the probability of the offspring's genotypes and phenotypes would be, we're going to look at all the possibilities. So to look at all the possibilities, you're going to distribute these letters throughout the Punnett square. The first thing you're going to do is you're going to start on top and you're going to bring the big B down to both of the empty squares below it. So now we're going to go over here. We're going to bring the big B down to both of the empty squares below it. Okay, good. Now, one thing to remember is if you have a capital letter, a big B, it always is the first letter. Just like when you're spelling or writing, capitals always come first. Now we're going to go to the right side and we're going to bring the little b across. So we're going to bring a little b to the first square And we're also going to put a little bee in the second square so it fills in all the way across. Go to the bottom one, bring your little bee to the first square, and then also bring it across to the next square. Now, this shows that if you cross a homozygous dominant round-shaped pea plant with a homozygous recessive wrinkly shaped pea plant, all of your offspring are going to be heterozygous. Hetero means different. Heterozygous dominant pea plants. So they all will inherit a dominant allele and they will all inherit a recessive allele because one parent only had dominant alleles to give, the other parent only had recessive alleles to give. That means, will they be wrinkled or will they be smooth? Well, they're all going to be smooth because they all have a dominant allele. The only way that you could actually get a wrinkled pea plant would be if you had two recessive alleles. Now you can cross this lots of different ways. You could have crossed a homozygous dominant with a heterozygous dominant and you'd get different results. But this is the basic process for filling out a Punnett square with complete dominance as the pattern of inheritance. Please use your practice packet to practice different variations on this and be sure to ask questions if you need help. Thank you.